Welcome back to the hyperbolic coding chamber. We are back once again, but most importantly, we are back once again with words from our great friends. We have a comment from Samuel. I have been doing this for about 30 days now, and your videos are definitely motivating. Feels like I'm not suffering alone. Feel strong, man. True. If you'd like to feel less alone, Discord. Shameless plug. But yeah, that's pretty cool. Yeah, that is true. That is pretty cool. I feel the same watching Ivan Jurik's videos, so that is pretty cool. And we have comment from ADC Robot. True. Yesterday's session was absolutely Trashington. I'm not really sure what the play is to fix that, but yeah, I'm not really sure. I think the last week was just difficult. So yesterday, just a lot of brain fog. I'm not really sure why the brain fog has been so strong. Probably because the stimulation has been so high. But I've kicked I've deployed all of the stops. So we should be able to get back on schedule. No more phone. So should be good. From Thomas Wong Coding, legendary programmer right here. Legendary programmer. Suffering makes you stronger. LOL. LC all day. Right. True. At this point, I would just like to I just want to finish all the problems, and then at the end, I'm gonna show up at the LeetCode offices, and I'm gonna say. Actually, I don't know what I'm gonna say. I'm also not gonna show up at the LeetCode offices, but yeah, it would be cool to get there. So that would be dope. We have a comment from Island Eagle, one of our great philosophers. Hey, I wanted to first say that keep up the good work. Your 158 days in which is a crazy accomplishment. I completely understand the situation where you sit on your phone and you're not productive for hours on end in the morning, as I do the same thing more than I would like to admit. True. This low key. This is one of the great. I feel like everyone does this, and it's just tough. The dopamine receptors are not prepared for what our smartphones have in store for us. It's okay to have bad days that don't work out. Not every day is going to be a good day. True. Don't punish yourself for something that happens to everyone. True. You are the realest, Eagle. Respect. Shall we? Need I say more? True. Yeah, I probably was a little too harsh yesterday. I guess some sessions just be like that. And you just gotta accept it. One must just accept it. Yeah, those last two sessions were so difficult, and that was very frustrating because I was hoping to make a lot of progress, and when I didn't, it kind of just made me more frustrated. So I gotta say I'm feeling a little clearer today. So I wonder if it would just I think it could just be like that. So I'm wondering if it'll be better today, and then we'll be able to create we'll just be able to create a differential on the LeetCode website. I'm hoping that the next algorithm we write takes the servers down because the time complexity is going to be crazy. And we have another comment from Island Eagle. Which wristwatches are Swiss wrist? You got me. He did indeed get me. And then we have a comment from Cam Cooner. What was the solution? Oh, wait, we have a lot more comments. What was the solution? He asked as he turned away. A question he had never thought of. That is the real question. If you mean Teemo attacking, I have no idea. The solution I don't think is that difficult. I think I've written a similar. I don't know what they call it. I think in psychology they call it interference or something like that. You have another memory interacting with another memory that's making it hard to just visualize them. I feel like I've written this algorithm a few different times when making games, but when I start thinking about this problem, my focal point slowly shifts to the algorithm I wrote when I was making games, and it's just hard for me to think about the problem. So I think the one issue why this problem is so confusing is because I've done it a bunch of times slightly differently, and then it's just hard for me to see the problem for what it is for some reason. It's like a thought loop. I'll be like, oh, the solution is A, and it slowly switches to solution 400 that I wrote when I was making like another game. It's just really difficult for some reason. I think it just be like that though. And Botea, why is it at 360? Oh no. I hope it's not at 360. I think it is at 360. I think it takes like 24 hours for the HD version to come out, but I'm not certain. Wolfgar, I'll check back though to make sure. Wolfgar says, you keep popping up in my recommended. Why are you doing this? I tried to see if you mentioned wine in your account, but can't find anything. This is the clickbait secret. So yeah, I was gonna put something in the YouTube description, but then we would get less comments. So I'm giving away the secret cheat codes. Why are we doing this? I'm mostly just doing what originally started as 2 years ago or a year ago. 2 years ago, I was doing LeetCode mostly to get a job because I just finished a master's program, and the LeetCode waterboarding had gotten pretty crazy, so I started doing that. And then doing it now, I mostly am just using it as a tool to train focus, because I remember looking back 2 years ago when I was doing LeetCode, and it was just easier to focus during that time. So for some reason, doing these problems, I think it's because LeetCode problems, or maybe math problems in general, have like this it's kind of like there's a sort of a binary answer. There's a binary evaluation. You can get it right or wrong, but the search space is so large that it's really creative. It's not like a game like League of Legends. You either win or you lose, but how you get there, there's so many different ways to get there that searching through that space, or whatever they call it, creativity, is kind of fun. But the slight differences in League of Legends, it's kind of hard to stay focused, at least for me. So something about LeetCode problems lets the focal point stay on the problem, the outcome stay binary, but the search space stay relatively unbounded if you exclude time complexity. And for some reason, it helps me focus outside of LeetCode. So I try to use LeetCode as a vehicle to train focus. And yeah, it does help. So focusing on these problems, or I guess I'm pretty sure you could do this with anything else. For some reason, focusing on these problems to solve them helps me outside of LeetCode. And that probably has something to do with how the brain in training focus or something like that. But my ability now at 157, I'm not that good at LeetCode, but my ability now to focus on something that I would not like to focus on has definitely improved. So maybe at 365, we will be unstoppable. Thank you, brother. So, yeah. That being said, there's not much to be said about continuing the suffering. So, today we'll be continuing with Teemo attacking. I've run into other problems like this before where the problem is really simple, but my brain is just having difficulty seeing the problem for what it is. I can't really explain it. It's like those puzzles where you see that there's like two people sitting at a campfire, but then if you zoom back out, it's two faces. It's like two old people faces and they're kissing. But for some reason, I just need to be able to see the campfire, but I can't stop seeing the two old faces. So that is what is really making me confused. So I just need to focus up, and it shouldn't be very difficult. So basically, League of Legends problem, Teemo tick. Our hero is attacking enemy Ashe with poison attacks. When Teemo attacks Ashe, Ashe gets poisoned for exactly duration seconds. More formally, an attack at second T will mean Ashe is poisoned during the inclusive time interval of T plus duration. Teemo attacks again before the poison effect ends. The timer for it is reset. I think I just realized why my solution may not have been working. Granted, this solution is kind of dead in the water. I'll try it one more time really quickly. And I think I just realized why that was. I also just realized I forgot to start the timer. Teemo attacks again before the poison effect ends. The timer for it is reset. Poison effect will end duration seconds after the new attack. No way. I didn't think simulation was an actual thing you could create. I thought I was overcomplicating it by creating a simulation solution. So maybe that's okay. I'm pretty sure, yeah, I knew it. I think we skip all this nonsense, and I think we just need to create a simulation. Create something like tick equals 0. And I think we just need to do something like this. Right? We'll have a tick, and we're just going to, the end of the time series is pretty much the last time in the array, plus the duration is the end of the whole time series, basically. Of the end of the whole simulation. Right? And then in here, we'll be doing the ticks. And I think time series starts at 1. So we can just start at 1 as well. Oh wait, time series sub I. No, it can actually start at 0. So we'll actually let it start at 0. And the question is, how would we do this? Well, for each tick that were less than the poison's end, if our tick is less than the poison's end, then we'd like to increase, less than or equal to, then we'd like to increase it. But tick also has to be greater than time when it started. So basically, I think we just need something like a poison start and a poison end. And if we had these two things, whenever we're in this range, we'd like to pretty much we'd like to increase the tick of the poison duration by 1. So you actually get poisoned at time t and t plus duration minus 1. So what we can do is just check if tick is equal to a time series we'll just create a set by passing in the time series, and then we'll be able to know whether or not a tick is a tick where Ash was hit. Then we can say poison start is going to equal tick. Poison end is going to equal tick plus duration minus 1. Then here we can say if poison end and poison start and poison and tick is greater than or equal to poison start and tick is less than or equal to poison end, then we can do something like poisoned duration plus equal 1. I should have checked. I don't even know why I clicked run. Oh. So now this is much better. We pretty much passed all the test cases. We output 500 here, but they output 501. Now I'm wondering if the problem that is arising is because of 0. Yes, so when 0 is included, we're off by 1. This is because I guess we probably should just set poison start and poison end. It depends though. It depends if it starts at 0. So if we'll say if time series sub 0 equals 0, then poison end actually equals, poison start actually equals 0, otherwise it equals -1. Actually, no, I think it's this part actually. We'll say if poison end is greater than or equal to 0, then I think we actually don't have to do anything here. Because when you're 0, we'll have the tick, so we'll update start and end. And so it should be included. Oh man, this would have kind of what I mean with the brain fog. Last 2 days I just couldn't think straight, and then I realized simulation was not a dog way to do this, because I thought simulation when I started, but I thought, I'd written a similar solution to this in other games, but those were simulations because they're real games. But I thought you couldn't do that in a LeetCode problem. So I was trying to write like an algorithm solution, but just made it more difficult. I didn't realize you could just write simulation solutions. So that is unfortunate. But yeah. It's kind of slow though. It is kind of slow. Is greater than equal to, and then poison start is greater than equal to 0, and tick is greater than equal to poison start, and tick is less than equal to poison end. Yeah, so this is interesting. I'm sure there's a way to do this. I'm almost 1,000% certain there's a way to do this just based on intervals. Because poison end and poison start are intervals. So you could probably extract the intervals out into time series. Start at 0. Poison end and poison start. the time complexity right now is pretty awful, where the number of ticks we do is just based on the largest final element, and that goes up. The length of the size of that value goes up to 10 to the 7. So that's pretty crazy. What if we just tried to make it an interval? It is an interval. Poison end and poison start. Ash hit has tick. End at 3. The duration would end at 3. Duration would end at 3. Interesting problem. Something was not satisfying about solving that. Given an array of strings words, return the words that can be typed using the letters of the alphabet. Return the words that can be typed using the letters of the alphabet on only one row of the American keyboard, like the image below. The American keyboard, the first row consists of the characters QWERTY WOP. Second row consists of A, S, D, F, F, G, H, J, K, L. Third row consists of Z, X, C, V, B, and M. Return the words that can be typed using letters of the alphabet on only one row. Oh, right. Peace touches all three, and Dad and Alaska only touch the second row. ASDF and SFD is true. I don't think this one's too bad. Word length only goes up to 20. I guess I'm thinking we could just create a set out of these 3 rows. And we're only considering lowercase letters. And then yeah, for a word we can check how many sets it satisfies. If it satisfies more than one set, then we just exclude it. So the time complexity of that. Maybe it could be 10. Maybe since the sets only include lowercase letters, and I think there's like 3 letters or 10 letters per row. Means you do around 30 maybe up to 30 operations per word. Maybe that would still be linear time. Seems like the operations we do would be based on the number of characters in this array times 30, which I think would just be O of S in the end. And I want to say it would be constant space as well. So yeah, I guess we can just create those sets. So we'll just say the new set QWERTY and then this one will do the same. Say answer is equal to this array will return answer. For const of rows, and I guess we'll just do for const of word, and we'll say if row dot has, if the row if the row doesn't have the letter, then we're just going to break. Otherwise, we'll do rows used plus equal 1. And we'll say if rows used equals 1. So we iterate over the words, then we iterate over the sets that we have, or the rows that we iterate over the letters in the word. If the row doesn't have the letter, will break. Because it's wait a second. If the row doesn't have the letter, so for example, O, it's not in this row. Only if the row, only if the letters in the words, the letters in the word are used in the row. All the letters in the word are from the row. Then we'll say if the row is used. I think the variable name I chose was confused because you can have partial use. Oh, I have this in the, wait. My screen is so small. So we check here. We have HELLO. Row does not have the letter. It does have the letter. No, it doesn't have the letter. Ah, I see. No, yeah, it doesn't have the letter. So then we go to row 2, okay. Does row 2 have the letter H? It does, okay. Does it have the letter E? Doesn't, so we go to the next row. Yeah, we didn't use any rows. What is going on? Rows used. I guess I'm thinking that rows used is getting really high. This rows used always goes up. I thought if you break out of the loop, but you end up just doing rows plus equal. If you move this up, we can do something different. So cars found equals 0. Otherwise, we'll say cars found plus equals 1 because it does exist. And when we do break, we'll end up out here. And we'll say if cars found equals word dot length, we can do rows. What is going on? Cars found equals 0. Oh, actually, it needs to start over here every time. That was not satisfying either. Maybe we're not thinking enough. Maybe I'm in autopilot and I need to actually just think. Yikes. You have N coins and you want to build a staircase. Has a lot of dislikes. You have N coins and you want to build a staircase with these coins. The staircase consists of K rows. You have N coins and you want to build a staircase with these coins. Staircase consists of K rows. The ith row is exactly, so you have K rows, 10 rows. The ith row has exactly I coins. So row 1 has 1 coin, row 2 has 2 coins, row 3 has 3 coins. The last row of the staircase may be incomplete. Return the number of complete rows of the staircase you will build. Complete rows. So I guess if we're given 5 coins, you can do 1, 2, 3, and the answer be 3. Oh no, right. I see, that's how it's a little confusing. We'll have used 6 coins total to do this. Jeez. N is equal. Oh my god. It looks like the Gauss formula could work. Maybe bottom up is crazy. Maybe you could just binary search. What if we just binary searched with Gauss? So we'll pass in a number, we'll return a number, we'll return will be this. And it's kind of nutty to make this a function, but it's just easier. And then let me just check if this works. Like, it should still pass the original 2 test cases. And then what we'll do is just do a binary search on the first number that is less than or equal to n. So to do that, we'll set low equal to 0 and high equal to n. And then let me move this out of the way. We do a binary search with Gauss while low is less than high. All right, we're gonna let our pivot equal to low plus the math dot floor of low plus math dot floor of high minus low. So to get the midpoint, let's just say we had 1 and 7, or 1 and 4. To get the midpoint, you could do high minus low, which would be 3 over 2, which would give you 1, plus low, which would give you 2. So to do that, we'd say high minus low, 5 minus 0. High minus low divided by 2. So 5 minus 0 gives you 5. For 2 gives you 2.5. You get, okay. Then we'd say G is equal to the Gauss of pivot. And if G is equal to n, we'll return pivot. Otherwise, else if G is less than n, right, then we can cut out. If G is less than n, then we can cut out everything. If the Gauss of the pivot is less than n, then we can cut that out by saying low is going to be equal to mid pivot plus 1, plus if G is greater than n, right is equal to pivot minus 1. The end, I guess the question that remains is, I think we can return low. I feel like this is, with some tweaking, this could work. I'm also not certain. Looks like I have off by 1. Looks like we have to do return high. Like, okay, low plus 1. feel like this works, but I don't understand why it works. It's like the concepts are really amorphous right now. It's clear that this staircase, right, that we're trying to check can be abstracted out into Gauss's formula. For example, if we want to know how many coins we used to get to this third step, it's just the sum of adding 1 plus 2 plus 3, and same if you go down to like 5 rows. We had 1 plus 2 plus 3 plus 4 plus 5. That amount is abstracted out into Gauss formula, which can tell us the sum of a series, or the summation of I going to n. Pretty much the sum of a series in constant time. Sum of a series in constant time. So this gives us the sum of the series, and we have to arrange the coins. Fourth row is incomplete. What they'd like us to return is a number of complete rows of the staircase you could build. Right, and what they're giving us is a number of coins we can use. So what we can do is just search between 0 and n and check what's the highest the Gauss formula gives it the Gauss formula the in, right? We can give it how many coins we have, and the output will get how many rows or the number of coins it took to build that many rows. So they want us to return the number of complete rows of the staircase you can build given n. Yeah, I don't understand why this works. I get it, but I don't know why I'm solving this, or why I was able to solve this. I don't understand. I'm just presuming that the solution does the same thing. Oh. Yeah, they're also using Gauss's formula here. They want to know the number of complete rows of the staircase you can build. The number of complete rows of the staircase you can build. Ith row has exactly I coins. The last row of the staircase may be incomplete. They want to know return the number of the complete rows of the staircase you will build. could also do this in linear time, I think, if you just count it up. As you could say I is less than or equal to n. Say 1 plus 2 plus 3. Then as soon as your number of coins is greater than n, you would stop greater than or equal to it. If it's greater than it, you would return coins minus the last step. Oh no, you just return I minus 1. Should be incomplete. Otherwise you would return. Yeah, I don't know why this works, but you know, we'll take it. I get why it works, but I don't understand why I thought to do it this way, but that is unfortunate. I know why it works. Actually, I don't. I just got an intuition that I could use GAUSS and binary search when I was reading the problem. But I don't know. Something's just fuzzy about it. But we'll stop there, and that is good enough for today.